Hello. Okay, yeah, it's working. Awesome. So if you're on the Zoom link right now, you probably just see a picture of me next to a plane. But if you're on the YouTube right now, welcome. Can everybody on the Zoom still hear me, even though I am streaming to both? Yay! And for people who want to join us on the Zoom, I'm going to be putting up ah, a link right now on the channel. And everybody who's on Zoom right now, give a wave to the internet because you're on the internets. Hi, internets. Hello. I hope everybody's doing well, washing their hands. Um, some interesting times to be living in, but you know what? We got our little group. We're just our little people. I think SLC Pythonistas, we can handle this stuff. Um, Sorry I can't order pizzas to people specifically today, and really wanted to, but it's just out of the budget. I just can't budget the time to do that. So, yeah. So instead, we got three awesome speakers, and we have our agenda. Oh, that's what I forgot to do. So, well, that's what I need to pull up. So I put the agenda up, but I'm not sure if I pasted a link, and I'm now realizing I probably didn't. So let me put the link up for everybody. And I'm going to paste that in the Meetup and in the Slack. So here's our agenda, and I'll also start sharing it around. Sorry, one sec. I know I forgot to do something. I have to make a new source. There we go. And I'll make it nice and big. So hopefully on the YouTube you should be able to see the agenda right now. And yeah, we'll just get through that. All right. Cool. So let's go through this agenda. I hope everybody can see that. So for people who don't know, Utah Python and SLC Python were started 5 years ago. Oh, sorry. Oh, so you won't see it on the Zoom. You'll see it if you're on the YouTube. You should be able to see the agenda. So we started in Sugar House Coffee when I saw a couple folks, Joe Reese and Ken Myers, were working on a little Python project. And I was like, hey, we should start a meetup group. So we started a little meetup group for the Python meetup, what, 6 years ago, 5 years ago now, Dylan? So started our little meetup group. This is our first fully online one. So bear with us for any technical difficulties. Had some fun setting this up the last couple days though, and I'm sure everybody's in for a treat. We have a couple websites, the meetup.com ones are up there. I'm gonna delete this because that's not next. Python Utah North, are you guys still hosting remotely? Louis?
we're hoping to be live in person next month. Uh, that may change. We might have to go remote.
Yeah, and we might have to go remote as well next month. But we're starting to write up documentation on how to host this stuff, and it looks like a lot of people are joining our Zoom, so that's just lovely. Uh, yeah. Next up on our agenda, we usually talk about Pi Ladies and all kinds of other meetup groups. Definitely check them out, hit them up. I'm not sure who's doing remote what right now, um, but if you do click on that Etherpad link, you'll see there's a bunch of meetups around the valley. Pi Data, is Joe Reese on? Oh, it looks like he's starting to hop on. So we'll say hi to him in just a moment when his audio hooks in. There's also, oh yeah, I should probably talk about, so Utah Python is the nonprofit that's kind of the umbrella organization for all of these little meetup groups. We provide nonprofit status and sponsorship of people, of speakers, of just all kinds of stuff that you would need to run a meetup, resources, meetup prizes, um, like documentation, things like that. So that's a fairly new thing as well, and that's Utah Python. Hey, is that JR? Is that Joe Reese? Hey, what's up, Joe? We were just talking about you in good ways. So, yeah,
Yeah, I
so
had to join on my phone because I don't have the Zoom. I don't have the SLC Python on my computer, unfortunately.
oh, no worries. No
Yeah,
worries.
if you could post a Zoom link on the Meetup, that would be handy, probably for other people who are
So I wanted
struggling.
to keep, actually, there's a bot right now that goes through meetups and finds the Zoom links and is just joining into them. So I kind of wanted to add another barrier by making people get onto the Slack right now. Um,
It's so secure, I couldn't even figure it out. So
yeah,
congratulations.
but yeah, it's a good point. This whole thing is being streamed live as well onto our usual YouTube. And yeah, but yeah, everybody give a wave to Joe. Hi, Joe. Hi. And to the world. There's a lot more people on. I
Hello.
like this. I like this virtual meetup. We haven't done one of these before, so I'm glad it's working out so smoothly so far. But I just jinxed it, didn't I? Anyway, let's keep going through our thing. We have a few websites, whatever. Maybe I'll find time to work on them finally, or maybe I'll just stay lazy. But there's GitHub repos if you feel like doing pull requests onto those. Sponsors, Xmission is still a sponsor. They have sponsored our previous pizzas, although they can't really sponsor everybody getting a pizza right now, although that would be hilarious. Pythonistas like you, so thank you for that. And previously, when we had a venue, it would be at the University of Utah, and we will return there once things have calmed down a little bit. Tech Systems has sponsored the today's Meetup prize. If I could show my video on Zoom, I would show it, but if you're on the stream, you'll see that our Meetup prize today is this Pi badge, and I'm kind of holding it up to the camera. So there you go. And basically what we'll do is we'll ship one of these to the winner today. And I think we'll do a couple drawings today for this. So that's pretty fun. Yeah. Let's keep going through this guy. Usually for our new members, we have a thing where we introduce our new members around. You say your name, your occupation, and something non-coding related. This time, though, I'm thinking what we could do is if you're new and on the Zoom, just unmute yourself real quick. Just say hi.
Hi.
Hey, Mick. Okay, so you get to
Hi.
go first. And Sharv.
Yes.
Sweet. Who else is new and on the Zoom?
I'm new.
Kay Sals, Scott Hastings. Who else? Anyone else? All right. Oh, Joshua. Well, welcome one and all.
Great.
This is our very, very formal Salt Lake City Python meetup group. We're not formal at all. We're very informal. Um, uh, yeah, and so what we're going to do is we'll do our intros, and that'll be your name, what you do, and this time it'll be your favorite indoor activity because of obvious reasons. So I'm Ferris. I am a software developer at Invitae, which is a genetic uh, analysis company. And my favorite indoor activity has to be video games. I was going to say reading a book, but let's face it, I've been playing way too many video games. So those are mine. Oh, there's so many new people. Mick, do you want to go next?
Yeah, of course. Hi, I'm Mick Zeller. I am a software developer at DDM. They're the digital arm for KSL. And my favorite activity indoors right now is just playing games, specifically Age of Empires. It's the best.
Very nice. Age of Empires is a solid game. All right, Sharv, would you care to introduce yourself?
Hi, I'm Sharvari. You can call me Sharv. I'm in my last year of master's degree in computer science at University of Utah. And my favorite indoor activity is cooking and doing yoga. I think after the pandemic, I'll probably come out as a chef.
Well, we can't wait to see you. Same with you, Mick. Everybody who's on virtually, we can't wait to see you in person. This is definitely an impetus for us to start getting more tools online as a group, but we've always kind of pushed for the in-person thing. And that being said, let's say hi to Scott. You're new as well. Scott Hastings.
Yeah, hi, Scott Hastings. So I am been in technology for a couple decades now, mostly in sort of architecture type roles. I'm actually, and then Python's a hobby of mine. It's something I'm trying to develop on the side. I'm actually between jobs right now, which is kind of an interesting situation to be in given the current circumstances. But it's all good. It gives me time to study and stuff like that. I struggle indoors, to be honest. I love being outdoors, but I think I was gonna say cooking, but Sharv took that one. My wife and I like to play games, like puzzles, and we found a cool board game that's new to us called Santorini. That's kind of fun. It's like 3D tic-tac-toe-y. I don't know.
That sounds awesome.
Yeah,
sucks to be stuck indoors. We've been trying to have socially distant walks every day, but it's tricky. It's tricky out there. K-Sals, would you like to introduce yourself?
Yeah, my real name's Kyle Salisbury, so I go by K-Sals, and I'm a chemical engineer from the University of Utah. Just graduated last year. I got a job down in Springville, Utah, where I design control valves, and it's been a lot of fun, and I love engineering a lot. Just like Scott, I do coding as a hobby. I like Python a lot, and my buddy Jake we text each other a lot about some coding ideas, and I'm just doing the best that I can to learn as much about Python and coding as I can. Right now, I'm doing some Django projects, and I'm liking it a lot. Favorite inside it activity, I guess it's Destiny 2. I've been playing Destiny 2 lately. That's probably like the number one right now is Destiny 2.
Nice. It's good to have a game like that where you can like work cooperatively. Personally, since people are saying game names, I've been playing Total War with a couple friends from college, and that one's a lot of fun because you can start a giant campaign and just keep hitting it with your same group of friends. So, all right, who else is new? Anyone? Going once. Going twice. All right, well, welcome new folks. We can't wait to meet you in person. Maybe it's next month, maybe it's not. Who knows how this will play out? It's probably not next month, let's face it, but that's okay. When things are a little bit more calm, then we will have the best of the pizza.
Let's ask for Tobias to come in. Apparently he's from Ohio.
What was that?
There's a Tobias from Ohio who would like to introduce himself.
Oh, can you hear me? Hello?
Yes, we can hear you.
Okay, yeah, yep. Tobias from Ohio. Doing an internship for a company called Implemented today. And what I do in my spare time is I play video games, MMORPGs, playing Elder Scrolls right now. So yeah, so how I found this was through just, exploring Meetup and definitely taking advantage of this, everything going remote. So just happy to be here and excited to see what happens. So.
Well, Tobias, congratulations on being the first confirmed out-of-state person to attend a meetup, our Salt Lake City Python meetup. Just curious, is there anybody else who's from out of state right now or out of Valley? It doesn't sound like it. So Tobias, you're in a really cool spot there. So you're wanting to learn some Python, it sounds like.
Yeah. Like definitely Django. I've seen that you guys are gonna be doing Django, right? Is that yeah? And yeah, very excited. Yeah.
Excellent. Yeah, so Dylan over here, Dylan G. Hi, Dylan. Dylan will be presenting on Django and Docker, and Ayla will be presenting on Graphene, which, if I'm not mistaken, is a GraphQL library. So that's going to be fun. But before we get to that, let's jump over to our who's hiring and who's looking. So it's better if you're on the Etherpad. I'm going to paste it in the Zoom chat and the Slack real quick. All right, so people should have that in front of them. And basically, what's cool about Etherpad is that it's kind of like Google Docs, where if somebody types, the other person types. So this is the part where we ask who's hiring. Um, this is the first time I gotta say that our meetup group has gone through, such a crazy market. So we've always had this for people who are new. We've always had a who's hiring and who's looking. So right now, if you know people who are hiring, it doesn't even have to be in the valley right now. The only condition is it must be remote, obviously, while this is going on. Um, because if they're not remote, we got to get you another job. But does anybody know anybody specifically in the valley who's hiring? Anyone? Or is there like a complete hiring freeze from places we know of? Okay,
We're on a hiring freeze right now, unfortunately.
yeah, a lot of people are. But let me
Same with
find, I
me,
got a
my
couple
company.
messages. I'm going to paste them in.
I think AWS is hiring from what I heard, but expect to be in queue with like everyone else.
Amazon Web Service, and it's probably better to get a certification as well, right? Do you want to talk more about that, Joe?
Can't say much about that. I don't know if that matters as much as just passing their very cryptic interview process. So,
All right. Who was it? I had one more that I will paste in. But yeah, it's tricky right now. There may not be places that are hiring explicitly. But you can always hit up Ferris. I'll even type that out. You can always hit me up for resume or interview advice. Just send me a message on Meetup. I've reviewed people's resumes and I've had to sit down with them. Todd can attest to the delicious Chipotle that we had while we were reviewing resumes and talking about places to work and things like that and career
I'm not
advice.
going to give Ferris too much credit, but I did get a new job the end of January.
Yeah, do not give me any credit for that. That's all you, Todd. Congratulations. That's great to know. Yeah.
Thanks. Thank you very much.
I'm gonna do the clapping emoji too, because that's fun. Awesome. Yeah, we're a very serious group. as you guys can hear. Anybody who's looking, and if you are, I would ask that you introduce yourself and then go ahead and paste your contact details into the Etherpad if you're looking for a Python-specific job.
Hi. So I am looking for data scientist, ML engineer job, and my primary coding language is Python. And I'll put my contact up in the doc.
Excellent. Thanks, Sharp. All right. Anybody else who's looking?
Hey guys, I'm looking. I've done lots of data science and lots of Python, and I'm looking around for data science jobs. Currently doing some contract work, but nothing. But just kind of getting by, and I have projects that I'm working on, but I'm open to job opportunities and working with people. So
Dylan is our #1 meetup speaker by quantity, not necessarily by quality, but definitely by quantity. No, he's amazing. Dylan, he gave a talk last month too, didn't you? So he just keeps rolling with those. Great asset for any team. Anybody else who's looking? Tobias, I see your name is starting to get written.
Yeah, so my internship will be, ending soon. So just looking for something, actually did a little bit of Angular on the front end and Django on the back. So just looking for something, remote, or even if I have to move all the way over where you guys at. So it doesn't, just pretty much that, yeah.
Excellent. Well, if you do move to Utah, definitely swing by the meetup when we're in person again, and I'm sure like 20 different people will surround you with different advice on which neighborhoods to live in and why Sugar House is just the worst. I'm just kidding. Sugar House is pretty awesome. Josh
that
is
would be
like,
awesome.
what the heck? Those were what the heck hands. I really like those. All right, anybody else who is looking? All right, and then it looks like, oh yeah, so Louis has a quick note about Score. Do you want to talk about Score a touch?
Sure. Hey, all. Just to let you know that over the last few weeks, I've been doing a lot of work with the Small Business Administration, SCORE, the state of Utah, you name it, the whole alphabet soup. So if you are part of a small business or have a small business or you work for a small business and they're having problems navigating all the ABCs and the alphabet of what's going on and what programs are available, shoot me an email. I'll set you up with either myself or another SCORE mentor, and we can talk about how to get 10 million bucks for your company, or maybe 10,000 or whatever's appropriate, and how to pick up a lot of the free money that's going out there. Because there's business loans and forgivable loans and grants available to practically everybody right now. So shoot me a message and we'll chat, and I'll point you to the right people. That's all I've got.
Thanks, Louis. Oh, and just FYI, I might refer to Louis as dad because he's also my dad. So that might be a thing. All right. So if people are looking for help, SCORE is an excellent, excellent organization. Every time I talk to my dad lately, he's like, "Oh yeah, I probably fielded, 200 phone calls today from panicking businesses." I don't think it's 200. I'm just going to exaggerate because he's my pops. So, all right, let's take a look. So, community news. PyCon 2020 is canceled, which lots of stuff is canceled this year. It'll be the year of cancellations. There is talk to push stuff remotely with PyCon. I'm interested to see how that turns out. If there are remote things, I would definitely encourage coordination on our Slack channel to do like a viewing party together, and that might be something that we can do as a group with your fellow Pythonistas. If there are a couple cool viewing parties, maybe those could turn into their own talks later this year. Other community news, and I will specify like community news refers to our Python and tech community, but everything's interrelated. So does anybody know of any Utah or Python community news? Any releases of Python? I think 3.8 came out, right? Yeah, I'm getting some nods. Yes, so Python 3.8. Any other fun community news? Or not fun news? I mean, PyCon being canceled is not that fun, is it?
On the remote meetup, I would say a virtual summit tip. There's was it Druid? They were going to have their Druid summit on the 15th in San Francisco, and they moved that to a virtual. And I think that might be one of the first tech summits out there that is virtual. So hit me up if you want a link to that. That's going to be really good if you're into real-time analytics. So
I gotta say, Tobias, you're really ahead of the curve here by hopping on Meetup and just finding all the remote ones for something you're interested in. Definitely, if you're looking for a reference letter, I mean, that right there, I'll write one just for that. Just say, oh yeah, he hopped onto my Meetup because he wants to learn.
Yeah, I definitely I went there and I was like, okay, there's got to be something, because I know here in Ohio we have a lot of virtual. Usually I attend a lot here in Columbus, and it's just like, wait, if we're doing it here, then they've got to be doing it everywhere else. So I'm attending one earlier today that was New York. I'm attending another one that's like all the way in California. I think is it California? Yeah, California. So I just have my schedule's like booked. Like, it's just I'm interested to learn. I just love that we get this opportunity to do this remote. Like, I feel like that's the future anyway. So.
Oh, excellent.
Yeah.
So with that, I think we're gonna get started on our talks. Yeah, so I got our first talk today. We always do like an intro to Python kind of thing. This is gonna be the most intro to Python talk ever. And I kind of made a fun video. So I would highly recommend, if you're on the Zoom, to hop onto the YouTube live as well. Just have that open on another screen. Definitely make sure you're muted because there's music and stuff. But yeah, so if you can see me on the live stream, you'll see this video I got was kind of inspired by, I just became a father, and also I got this book and a bunch of other picture books, but this is Quantum Physics for Babies. Oh, and you might not see it right away, by the way, if you're on the Zoom. There might be a bit of a delay before things show up. But anyway, this is Quantum Physics for Babies by Chris Ferry. And I really liked this. And I was thinking, what would Python for babies look like? So I kind of made this video. All right. I think there's a bit of a delay with the video. So I really want to share my screen on Zoom so that people can see this, but it's probably, again, it's a little bit better if you look at the YouTube right now. But as you can see, that was just some chalkboard coding. You could probably, you can't really code like that, obviously, but the point is to show, how to kind of decompose the different parts of Python. Something that I always kind of push is, hey, think about nouns as nouns and verbs as verbs. In this case, we had our pillow, that's a noun. Our swaddle, that's a noun, right? The little wrapping thing. And then the baby, but the swaddle has a verb associated with it, and that's folding. And then, baby is what you're going to fold it into. These things have names. They have, like we call them parameters, we call them objects, and everything in Python is an object that you can do stuff with. So that was just kind of an introduction to like the syntactic sugar of Python. And yeah, are there any questions about the video? We're going to get into more advanced Python stuff soon, but I just thought we could have some fun on this April Fool's on our first remote meetup.
Yeah, it might just be me, but I think the video is just now about to play.
Oh, there might be a bit of delay with that.
Yeah, it's several minutes for sure.
For me, it's only about 30 seconds.
Yeah.
Sorry, I just saw the video. It is very cute.
Sherry liked it. Dylan liked it. Yay. Well, I'll try to fix that delay for next time. That's for sure. Wow. For people who have had a chance to see the video, that's kind of it was kind of just a random idea, kind of combining a couple things that are happening. I just had my first kid, and I also figured, hey, this would be kind of fun to show how can you teach Python concepts with just a chalkboard. And I think it's all about representations and things like that. Yeah. Let's see. So I am going to put us in transition mode, and then Dylan, did you want to get your talk ready to go?
I can get my talk ready to go.
Yes, so for everybody else, you can present through Zoom. Because this device is also being used to stream, I can't.
You can't do it. Okay. Alrighty, friends. Welcome. So my talk, let me share my screen here. Nope. I jumped to slide 1. Okay, so I was putting this into, a lot of the inspiration of this came out of, I got really into doing a Docker setup with Django last week and trying out different database backends and kind of going deep on on my opinions on top of Django's opinions. And I thought I kind of wanted to talk about some of those pieces and present those. I think Docker is a really powerful tool. If it was easier, I'd do like a raise of hands of how many people have been using Docker, but it's become essentially the industry standard for, yep, I see some thumbs up, for doing code. So let me walk through. I have kind of a what is Docker. So for people who are just totally unfamiliar, It's a tool that helps build applications and then deploy them. The main unit of what it builds is a container. And so a container is essentially your unit of software. This is the thing you want to run, whether it's a web application. Like desktop applications are starting to become containers. And what it is it contains not just the code to run, but all of the binaries and all the libraries that are needed. So a traditional executable is kind of your binary code to run, but executables will often depend on other libraries, C code or things like that. This is similar in that it's the thing you want to run, but it's all of it, all bundled together into one. Loading. Loading. I've been having a few odd internet things today.
I think the internet itself has been kind of odd today. There we go.
I have a virus.
Just stop. Oh God.
It doesn't have it's not showing slide 4. I wonder if I can just show it over here. Create more presentation screens.
Sure.
All right, we're just gonna show it in the preview. Here. Okie dokie. And then I'm gonna just do. Okay. All right. So a container is similar in a way to a virtual machine. So when development switched over to using virtual machines, it was essentially this same idea of like bundling something together so that it will run. But a virtual machine contains the operating system as well. The operating system is what ends up talking to you, it schedules jobs for the machine, and then ends up talking to your hardware and back. So containers, on the other hand, you have, here it shows 3 different containers. The container has all the app code, all the bins and libraries, the Docker engine, which is running on the operating system, and but no operating system itself. So it leverages the utilities of the operating system without having to contain it as well, which makes it a lot more lightweight and a lot easier to move around and deploy. So some of the benefits, the biggest one is portability. So when I build a container, I can then give that container to somebody, and it contains all of the libraries, all of the application code. So there's no longer this like, it worked on my machine, I don't know why it's not working on yours, because I have some library that you don't. This contains all of the pieces, and all you need is the Docker engine in order to have your container talk to your operating system and back. But the Docker creates this abstraction layer so that containers, you can pass off containers to basically anyone that also has Docker engine. It also provides isolation from other applications. So this is a benefit that came out of virtual machines as well, but it isolates one application from the other so that they don't, not that they don't compete for resources, but that they don't have to rely on the same libraries, so you don't have conflicts, and also so that they can't interfere with each other, so it adds some security. But yeah, I'll talk about it in a second. So the composable deployment. So composable deployment means I could have containers that represent particular pieces of work. So I might have one container that's a caching system, one container that's a database, and one container that's my application code. And I can mix and match those. So Docker provides this ability to mix and match those. And then along with that is orchestrating how all of these things talk to each other and how things scale. So there's tools like Docker Swarm or Kubernetes, in which you can create multiple, you'll have your servers as a cluster, and you could deploy containers. You might deploy 3 containers to run your application, or you can deploy 4, and it's just a simple configuration to do that at this point. So we're taking a lot of things that were scripted or that were hard-coded, or people were going in and creating these systems and abstracting it into configuration and using Docker as a tool in order to make that configuration actually run our code. So some caveats: they are not virtual machines, so they do have some shared resources with the operating system, but it is in kind of it is in a controlled way, so the way that your application will access the operating system and back. There's some overhead for any of these, so if you have something that really needs super speed, you wouldn't put it in a container because it is still running, it still has these layers of abstraction. That said, you get the benefit of flexibility, which is a lot of the reason for that we end up prioritizing the speed to develop something and ease of maintaining it over speed. So this is kind of the same reason that Python is a great language and has grown, is because it prioritizes being able to write the code quickly and efficiently over always having the most optimized speed. Now, Python's also great because you can extend it to C if you really need the speed. But in the same way, containers prioritize being able to have this flexibility with some overhead. Now, that overhead's a lot less than a virtual machine would have, and so that's part of the reason that it's catching on as a method over virtual machines. Another thing to note is that containers are stateless. So say I have a database container and I run up the database container and I put some data in it, and then I take down the container, it will lose all of the information about what its state was or what was in it. And so in order to maintain state, you have to put that somewhere, usually some sort of drive or something that's mounted, some storage that will be permanent. And I'm going to show you some solutions for that with my with the Django component that I talked about, the example. Okay, so now I want, let's see, on containers and Docker, how are we fielding questions, Ferris? Like we have like 4 different communication tools going, right? Okay.
And if you're listening online, yeah, Dylan just asked how to field questions. If you're looking on the YouTube live chat, feel free to paste a question in there. If you're on the Slack, feel free to ask in there. And if you're in the Zoom, feel free to use the Zoom chat so that we don't interrupt Dylan, or if Dylan opens up the floor for Q&A, go ahead and just use Zoom.
Okay. Yep. That sounds fair. So, and also, if you can keep track of those, Ferris, as we go. Okay. I'm very much open to having discussions, especially with those here on the Zoom, where we could have like a live discussion. If you feel like there's pieces that you would like to add about Docker, about containers, or about Django when I get to it. Okay, so a container is your unit of software, and containers are built from images. An image is a static store of all of the application codes. When you actually download the binaries, imagine taking all those binaries and then bundling them together into a zip file and those would then, you could then pass those around. And so that's really your image. And the container is actually taking that image, mounting it on top of your operating system and running the code. And there's a Docker file. The Docker file is the description and all the commands of what creates the image. So this is download this thing, install this, build this binary code. And so you go from a Docker file to an image to a container, and that's sort of the progression. So I have an example here, which I've put together for this particular Python meetup. All right, I'm gonna minimize that. My crash course under the web app. All right, so let's open it up this way. Nope. Zoom's in the way. All right. So I have this simple hello world example in which I have my Docker file and an app.py. So if we look at flying windows, the Docker file itself. So the Docker file is this set of instructions. And so this says from a base image, which is Python 3, create a working directory, copy all of my code there, and then the command to run is Python and app.py. And so my app.py code here is, this was old. So my app.py code is import time, and then I go make a little loop. I print out hello Python and sleep for a second. So if I go, let's walk through the pieces that I talked about. So the Docker file is the description, which I just showed you. The Docker daemon, the Docker engine itself, is a command that I can run from the command line. And there's this command, docker build. I can give a name of what I want to build. So you often end up naming them so that you can keep track. Latest, and then where all of the context of the build is. So where is that Docker file? So I'm saying it's in the current directory. All right, so Docker then builds all the instructions. It does it in a stepped process, and it caches each of these steps. So if I go in and change one of the steps, so say I change where it's located, and I rebuild. Oh, because that was one of the early ones. It's removing an intermediary container and then builds it. So this is a really nice feature of building up environments, is that using Docker, it will stage these and cache them along the way. All right, so now let's run my example. Let's do it from here. So the run command, docker run, I give the name of the container, and the -d is going to be, I'll type it out here, docker run name crash course. D says make it detached, so don't take up my screen with it. Docker crash course latest. So this is the image in which I want the container to run. I already have a container named that. So if I want to view my containers, there's a Docker container ls command. So Docker container, this will list containers that I have. These are the containers that are running, and this is all of my containers. So you can see I have a bunch from past meddling around, and we're just going to do this Docker prune. I'm going to remove all stop containers. Yay! And Docker container again. ls.
Like, wow, that's a thing. I always write fancy awk scripts to do that.
Yeah. Yep. There are some hidden things within there. I'm also going to talk about Docker Compose in just a minute too, which helps with some of these commands. So Docker container, I'm going to kill this particular container. So Docker container ls, I have 0 containers now. So if I go back up to my run command, so that starts up the container. I can see the name here. So if I do my Docker container ls, it shows my containers running. I can also do Docker ps. So similar to my operating system, like the Linux operating system, the ps command shows you current running operations or commands. So this container is now running. Cool. How do I know it's running? Well, I can look at the logs, the log output from that. And I'm pretty sure that the log output stops, so that I get the logs after the container stops. So let's actually kill that container. View the logs. So this is an interesting one because I haven't. So I was putting this together and just learning about how the Docker logs works, because I usually access this through Docker Compose, and Docker Compose is a tool that actually abstracts some of this away. It's basically just helper tools around Docker itself. With Docker, you can as well add these flags IT. So interactive and terminal. This is going to actually create a TTPY connection to the terminal application that's running your command within the container. So I'm going to capture, oh, again, I have this running. So since I already have it running, I can actually just give the name now. Or since I already have the container. Aha! Applause. Applause. Yep, thank you, thank you. All right, so what's happening here? We have the command running, we have it interactive, and we specified the container in which to run. So it's actually, because it's interactive, it's listening to my input from the shell. So when I do Control-C, it actually sends that interrupt to the application. And so if I, you can also do things like I can overwrite which command it runs. So when I was running before, I was running the default command, which was specified in my Docker file, but I can write a new command, bash, and so now I'm actually essentially shelled into that container. I've done, it's listening to my commands because of the interactive, it's giving me the output because of the T, and then it's running the bash command so that I'm actually like inside of the container as it's running. So now I can actually run the command I want like this. Ta-da! I find this ability to run bash really powerful because I'm often, I don't know how many other people are, but I like, as I'm building these containers, I'm often like just jumping in. I'm like, okay, just put me into the box so that I can figure something out. And you're within this container. So if I wanted to install or run any sort of other command, I could. So the Utah command that Ferris created, or the Utah library, I can run the interactive terminal. What's the thing you have in here, Ferris?
Mic on.
Yeah, I know, but I can't remember what actually is in the Utah.
You have to do from Utah import. I think it's Meetup.
Meetup?
Nope.
SLC Pi? Nope. SLC?
Hold on.
Python
It's
and get some
from Utah. Import SLC Python, the whole thing.
Ah. Nope.
Oh, I guess it's not fully installed. Yeah, this is what I get for not maintaining my code.
Okay, so the important part here is the import Utah. So that library loaded. So now I exit out. If I run it again, right? So if people remember, I said it's stateless. Insert Utah, no module Utah. So it doesn't remember things from run to run. So this is where if you want something in there, you got to add it to your Docker file. So in here, I might add something like, let's do this live. So my requirements.py, in my Docker file, I'm going to copy requirements.txt, run pip install -r requirements.txt. Copy that here. So copy is moving the files in. The run command is something that you execute. And so if I go back and do my Docker build -t for this, it's going to copy over that requirements file and actually run the pip install. And now if I go back and run this command, which I did before, import Utah, it's there. More applause. All right. Thanks, Ferris. So this comes back down, part of this is a forced decision so that the Docker container itself really does contain everything. I can't go in and modify it and then be like, oh, well, mine has these other pieces and yours doesn't. It really is the whole container of all of the stuff that you need going forward. All right. So Docker has several, you have Docker, remember you have your Docker file, which is your set of instructions, your Docker image, and this is all the static content. So you can see all of the images that Docker is, that you've built, that you have locally. And then Docker container is the actual containers that it, container ls. These are the containers that you've built and can run. All right, are there any questions on that? Looking at you, Ferris. Yeah, let's do them.
Mr. Josh Gardner.
Okay.
So what's the difference, Dylan? Jeez.
Oh, the difference. So a virtual environment contains the operating system. So the operating system helps when you want to run a program. It is what is actually allocating which program runs when and how much resources it takes up. So your computer has a lot of processes running all the time. And the thing that keeps them from competing and the thing that makes sure that they don't write the same memory or use the same memory, that they have some amount of separation, is pretty much what your operating system is helping to manage. And
mic off.
Clarify?
Go ahead.
No, so the question isn't like what's the difference between virtual machines and containers. It's more of why use Docker instead of Python's virtualenv.
Oh, okay. So the reason to use Docker instead of virtualenv is because it gives you, so it's about the other library dependencies that you have. So if I, on a regular machine, try to pip install, this is SLCPython. So I'm not sure if this will show up on mine. So I have virtual environments. It's SLCPython. Okay, so boom. Okay, so this is a problem. I've run into this before. That's why I know. SLCPython depends on a system binary. It depends on a Postgres translating binary that I don't have installed. And so even though I'm in a virtual environment and using this, it's actually using other things within my operating system that I've installed that are not explicitly part of the software of the virtual environment. Does that make sense?
It does. I have answers to this too. I just figured other people might have the question, so I asked it. So why don't you show the how to address this with Docker?
Yeah. So in Docker, man, so in Docker, what I'm going to do is, so say I have the same sort of setup script we were talking about before, and I have that same requirement now, SLCPython, and I need to install
PostgreSQL-dev.
that. What is it?
PostgreSQL-dev.
Oh. That one?
Yeah, without.
Yes?
Mic on.
I think you need
So,
to
mic off. Mic on.
Probably not, because inside of the Docker, it's going to be a blank environment. So it's going to just give me the most recent one. So I don't need to update because there's nothing there. Right?
All right. But I usually have updated my script.
Okay. So Docker build. So we're going to rebuild. Nope.
Yeah, try the update.
Update like that?
No, it needs to be apt-get update $.
Oh, I see what you're saying. So you're gonna update apt-get itself, and then to make sure it's got the most recent libraries. So that's still dev. I think that one might work. Yep. So now what's going on is I'm actually installing this binary, this library for PsychoPG that PsychoPG uses. So then when it actually installs PsychoPG, it has that binary for it to use. And so this comes back around to this.
All nicely.
Say that again.
And it can compile it.
Yep. So there we go. So now this idea of portability, if I give this over to somebody, it has that library alongside of it. This is what makes it more powerful than just the virtual environment Python. So with the cost of the Docker overhead, which is minimal, you have this ability to port it and give it around to people and deploy it easily. Cool. Other questions?
Let's see. So, one more thing that Ayla had to add on to that. A reason that you would use a Docker versus a virtual environment would be for process isolation. So Ayla says Docker allows process isolation and can limit how much of the host OS resources processes use. So that's a really good point there. Louis Shabib asks, can Docker files be secured? It looks like there's already a bit of discussion on the Slack about this. Specifically, I think, are you asking about the file itself or the image running the like a running image and how you keep security? Looks like there's some answers already in the Slack. Louis, do you want to touch on your question a little bit more?
Well, I was just wondering primarily, and I think a lot of it is discussed in the Slack. Obviously, you don't want to put passwords and key components in there, especially if it's sharing. But what about the file itself? Do those files live in a secure environment, or do you recommend making a secure environment for them?
So I can actually touch on this a little bit. So at my work, something that we do is we compile a lot of genetic databases, and those databases have credentials that we don't want to commit to a repo. So a lot of the places, or a lot of the ways that you deploy a Docker image is you'll actually set environment variables. Yeah, and Josh Gardner in the Slack just got it. So something that we use is a .env file to kind of keep track locally, or you can use that for local development, knowing that you will set an environment variable on whatever host process is going to be running your Docker. So for example, and just so to be more clear, those environment variables, they are just key values. So you could say database password, DB password, and then that would be set on the host and no one else would have access to it. It wouldn't be committed to a repo or anything like that. Another point that it looks like is being brought up by Nick, there are a few security concerns. For example, if you use an environment variable to set up a private PyPy and install, the secret is in the environment variable, but now it's on the Docker layer. So even if you delete the config as part of the build, there are some considerations. If you run Docker in production, you got to make sure you're not running as root. And a lot of this stuff is mitigated by using someone else's hosting. But if you're trying to do this yourself, definitely those are some things to consider. Let's see, what other questions do we got? runtime environment variables. Yeah, there's actually a really good discussion on the Slack. Are there other questions coming in? I'm not seeing any on the, nothing coming in on the stream. They are 30 seconds behind.
Depending on your internet speed.
Yeah, I found out why, by the way, for people who are just tuning in. It's because there's a button that does ultra low latency, and I forgot to hit that button before I started the stream. If I set that button though, the quality of the stream, so for example, like all this text and stuff being displayed, it'll go down a little bit. I'm not sure what it'll do for the VOD, which is to say the recorded video after the stream, if that will also have the same low quality. But next time, yeah, I'll make sure to lower the latency a lot.
So on the topic of secrets and environment variables, one way to think about, so I said that containers, one way to think about them are as executables. So they're one chunk of code that contain everything it needs to run. And this is like a super executable because it also contains side binaries and things. When you have some sort of executable, you give it commands, right, that execute at runtime. And those those variables, those arguments that you pass in to command's the wrong word. The arguments that you pass into your executable, your container, the way that a lot of DevOps systems do this is by putting environment variables in at real time. So they'll spin up the container, stick in some environment variables, and run your command. Now you could have your command have flags, or you can have your command just look in the environment for those variables. So if you have some secret, that secret only lives when you actually run the container. The program will put the secret in and then run your code, and your code just looks for that secret and pulls it in. So that's sort of the best practice now, is that your application should pull out all of your configuration and things like secrets from the environment itself.
And there's a lot of technology available for managing secrets. There's stuff like Vault. Every cloud service has its own secrets manager, which you should be using if you are running on that cloud service. So yeah.
Cool. All right, let's see here. I think I'm going to, stop there actually for my presentation and just mention my repo that you could go check out for some other things, and maybe show you a demo of it as like a teaser, because I'm already into this a bit more than I think my original allotment, and I want to hear Ayla speak. So I'm just going to say, so I have this, I'm going to just show you what I have set up here. So I have a Docker, I have a website that I made using Django, and you can see, I'll post the my own little boilerplate into the link for this. This is on my repo it's a repo on GitHub. So Earth Astronaut is me. And I'm essentially kind of putting together the Docker environment as well as how I like Django set up, where I have different things live. Coming back to, yeah, so let me mention Docker Compose. I kind of set it as a way to put a lot of this Docker stuff together and make it easier to run. So in Docker Compose, it's essentially just a configuration file, and it's a bunch of helper functions for Docker. So each of my services becomes its own container. And so this is where the idea of composability that I mentioned, where you can have different services working together. I'm going to have a web server version, and then I have a database version. And in this case, I have two different databases. And so I can have all of these services running and create a virtual network for them to talk to. And so this creates a powerful way for me to take chunks of code that are packaged and ready to go, right? This idea of a container and portability, and make them work together in a way that I can change up very quickly without a lot of extra coding or making sure that things are put exactly right. It relies instead on common things like network talking and how they talk over the network, which you would have in a real environment as well. So a lot of the time you might start with something like this that will have several services. You might run them on your own machine, but Docker can allow you to run each of them on a separate host so that you could add specific resources to that host. So because, where'd you go? I'm gonna minimize this one. Okay, so the main command instead of Docker now is Docker compose, and there's a build command. So just like the previous Docker compose, or just like Docker itself, it has a build, and it goes through and builds each of my containers. So here you can see I've essentially already built all of them before, so it's using cached versions. But inside of here, I have that same Docker file that's specifying where to build from, environment variables. So some of these things that I didn't touch too much on environment variables, but in the Docker build, you have all these commands for what it builds up to create the image, which then the container runs from. So I built all of my different services, and now I can start them with Docker compose up. And so this is actually running that interactive version where it shows me what is happening. So it's got that interactive ability, and it has all of the output from my different services running. So instead of that longer Docker command, it has a simple Docker up, and I could also add in just the name of the service. Done. Okay. So now I have a website running. So you can see here, I have the output from my actual server on the left, and I have the actual website running on the right. I created a very secure admin user, and it pulls up my website. So this has the database and the web server both running in containers and talking to each other, so that I can run my service. Okay, so that was my little teaser. Docker Compose helps make Docker a bit easier. I hope people have a better understanding and just feel totally solid on what Docker is now. And if you have any last questions, we pretty much already did, but any last questions, you can put it in the Slack. I'll be in the Slack, and thank you for your time.
Thank you, Dylan. Clap emoji, clap emoji, clap emoji. Just sending all the clap emojis right now. And I'm going to stop your sharing right there. There we go. Oh, hello, everybody.
Hi, Ferris.
There we go. All right. So it looks like Ayla, you're up next. Oh, Dylan, if you could do us a favor and paste your slides into the Slack channel as well when you have a moment.
Yep.
Yeah. Ayla, are you ready to go, or do you need time to transition?
I need time to transition, and I think everyone should stretch a bit because we've been sitting for a while.
Yeah, I think that's a good idea. If
Ooh,
you
squats.
if you want to look at some nice fishies while you're waiting, I will put that transition on. That'll be relaxing. In 30 seconds, it'll be relaxing. So yeah, let's take a 1-minute intermission. I gotta refill my water over here.
Mic off.
Hopefully. Yep. Okay.
Yep.
So if you scan the QR code, it will take you to the GitHub link that's at the bottom. I will also paste the GitHub link into the Meetup chat and the Slack chat. This is basically the code that I wrote to go with this presentation. I've cut this down from a longer conference talk, and depending on where people's energy levels are, I may omit the end. But let's just at least get through the first part where I explain what GraphQL is and some stuff about graphene, and we'll take it from there. Now,
Mic off.
if you could like give me a thumbs up or something if you've ever worked with Flask or SQL Alchemy or even GraphQL. Yeah, because I think that will make some of this a bit easier, but I will try to break this down. And also, please feel free to interrupt me or Ferris if you're reading off the questions in the chat.
Mic on.
If something's unclear. Because if you haven't seen GraphQL before or done a lot of REST API work, some of these concepts may be unclear.
I got your back, Ayla.
Thank you. Oh, how do I? PowerPoint. Okay, so the
Mic
fundamental
off.
question is, what is GraphQL? Basically, it's this open source query language that Facebook came up because they were faced with this problem when people started to move over to phones. They had to make mobile apps efficient on unreliable networks with limited bandwidth. If any of you are familiar with the fallacies of distributed computing, one of them is the network is reliable. It is not. The the network is very unreliable. So instead of trying to go out and fetch a whole bunch of URLs and assemble them into a web app the way you could in a web browser, they needed to come up with a better solution to present data fairly quickly. Also, it features declarative data fetching, which we'll see later why that's a good thing. And because Facebook, they deal with a lot of connected data. How do you represent connected data? You represent it frequently as graphs, nodes and edges that kind of look like trees or networks. So Facebook thinks of data in graphs. So therefore they called it graph query language. So initially they developed it. It's hosted now by the GraphQL Foundation, and that's also part of the Linux Foundation. And here is our hello world. So graphene is a Python. Oh, did I skip a slide? Hang on, sorry. Nope, maybe I didn't. Okay, so this was, graphene is a Python library that allows you to implement GraphQL. Facebook itself created a JavaScript distribution called Apollo, which is extremely popular. But since we're Pythonistas, we're going with Python. Basically, what we have here is import graphene, and then we have a class called query, which organizes all the code we would need to actually get information from your GraphQL API. The root field is called hello, which is basically that very first statement. And then we have to have a resolver function, which then gives us back the data that the API expects. So in our case, it's just the word hello and an optional argument. If you do not supply an argument, then it will simply return hello world. And then once we have this query class declared, we return a schema and give it the query class that we've declared and implemented. So again, the root field is called hello. We're seeing this in kind of a JSON-like serialization format. This allows us to say, okay, I'm going to connect to you and I'm going to ask for certain kinds of information. In this case, it's the hello field. And then when the schema executes, it goes and resolves that hello field and returns some payload. And that would be hello world, or if I give it a query with an argument, that's hello universe. Okay, and here is what that sample code prints out, as I said. So fairly straightforward in this very basic hello world example. Sorry. Okay, so again, what is GraphQL? Query language. It describes your data requirements. It implements your basic data operations that you would normally see in data-driven applications. CRUD would be create, read, update, and delete. In a REST API, each one of those would be implemented with like an HTTP GET or an HTTP POST or other operations. There's a delete, there's patch. In GraphQL, you basically have two, those are encapsulated into two operations. Read is mapped to query, and then create, update, and delete are called mutations. The GraphQL specification has a very strong type system. It gives you a schema definition language and static validation. And GraphQL implementations like Graphene enforce type validation. We'll see a little bit of that later as I start showing you more specific examples. Another thing that GraphQL offers are real-time connections to servers called a subscription. I'm not actually going to be showing any code for this, but it's good to know that it exists. It's event-based, so when a mutation changes some data in the data that your GraphQL API is managing, you can get an event-based update and get the changed data payload. In many GraphQL implementations, this is implemented with WebSockets. This is definitely true for Graphene. I'm not completely sure about Apollo, though. But since JavaScript, we won't worry about it. So the GraphQL schema language is made up of some the scalars you would expect to see, strings, various numerical types. You also get lists, unions, enums, which kind of look like Python enums, and you get interfaces, which would allow you to declare data types. It kind of feels a bit like a Java interface. And then you can also get type introspection. So you can say, okay, here is my schema. Give me all the types. And if you've declared your own data types, which you can do, it will give you a breakdown of what that data type encapsulates. And then also, the spec defines some execution semantics. Queries, because you're just accessing data in a read-only fashion, can be executed in parallel, but mutations, because they are actually changing data, have to be queued up in a serial way. So this is defined in the GraphQL spec, but it is enforced in the implementation. So, people have been using REST APIs for a long time. HTTP operations do work fairly well. Why are we introducing a new tool to do data manipulation over the internet? Here are some good reasons. With GraphQL, you can get requested data only. You can say, okay, I only want these fields in the payload to be returned. We'll see more specific examples as I continue. But what this means is you don't get over/under fetching of data. GraphQL also declares a single endpoint instead of multiple endpoints with various resource names and possibly IDs. So it does make managing this in your application quite a bit simpler. It also allows you to combine data from multiple sources. If you've got a couple of different databases where you want to fetch data, write queries, and stitch the data together, GraphQL is actually a really good solution for this. Apollo, the JavaScript server, actually comes with some stitching tools that save you writing a lot of code. Graphene doesn't necessarily, but there's ways of implementing reasonably efficient code to do this. Also, GraphQL is good at describing data relationships, especially if you happen to have connected data. Another reason to use GraphQL is the GraphQL spec happens to have deprecation built into it. You can, if you want to change a field type or a data type, you actually can explicitly mark a field as deprecated and give a reason for it. So it is documented. And I'll show you what documentation in GraphQL looks like as well. There's also built-in pagination and slicing of lists of data. The event-based subscriptions is powerful. It's strongly typed. You can get detailed errors, especially type errors. And it comes with, the spec doesn't define this, but pretty much every major GraphQL implementation gives you an in-browser IDE, which gives you a very tight feedback loop when you're designing a data-driven service. It's actually really handy. So with every great tool, though, there are some good reasons for not using it. GraphQL can sometimes end up with a schema that looks exactly like your database. There are tools that you can use to help reduce this duplication and reduce the amount of boilerplate you have to write to access your data through a database, but it is something to be aware of. If we go basically to the end of the presentation, I've got some code in a tool called Relay, which helps cut down on some of this boilerplate. Schema design becomes harder, though, because we are modeling more complex data relationships. It is possible to write very complicated and very bad schemas. I've actually seen this happen. So being mindful of making your data representations too complex is something you have to be aware of. Your query complexity also goes up. Instead of just sending a URL with some query variables, you're actually sending a JSON payload, and that comes with its own complexities. And oh yeah, it's also possible to make a schema with too many nested fields, which makes it harder to manage. The learning curve can be a bit steep on learning how to handle all this. And also, one drawback is it's fairly easy to implement rate limiting in REST APIs. It is less easy to do it in GraphQL. It pretty much has to be baked into whatever GraphQL implementation you're using. As far as I know, Graphene is only so-so at this. Another problem is expensive data operations on the server. Depending on the kind of database you have, if you have to pull a lot of data to satisfy a query, you can get your database operations do become a bottleneck on the server. And if you have to do a lot of joins, that's another problem. HTTP allows fairly easy in-browser caching. You kind of lose that with GraphQL. And also, if you're just writing a fairly simple data service, or you just need to offer up some very simple endpoints, you're probably better off using REST. So, just some caveats to keep in mind. How's everyone doing? Are we good?
Mic on.
Okay, fantastic.
Mic off.
Okay, so I described Graphene a little bit to start. Formally, it is a Python library to build a GraphQL API, and it is designed with a code-first approach philosophy. That means that the schema is described in Python code instead of a schema definition language. Graphene then takes the Python code that you use to write your schema, as I showed in that little trivial hello world example, and translates it for you to a schema definition language
Mic on.
that matches the GraphQL spec. You can use Graphene with either Flask or Django. I picked Flask for my application just because it's very simple to throw together a teeny tiny application with very few lines of code. But this works awesomely with Django. There's a ton of really wonderful integrations for Django as well. So if you really need to write a powerful web app, you're probably better off doing this with Django. And it also gives you the execution engine that lets you satisfy queries or perform mutations, and implements all the execution semantics that I mentioned before. Oh yeah, also this little sample code I put together uses a SQLite database just because it's super simple. But you can write Graphene services with Graphene that will connect to pretty much any SQL database you can think of. At my previous job at ARUP, we connected this to Mongo databases. So, it can work with just about any database you can think of. Here is the breakdown of the little sample app I wrote. It's got an app.py file that contains the endpoint, that little bit of Flask stuff you need to get the application running. There's a database.py file that basically reads in the SQLite database and gets the data. We have an object relational mapping in models.py through SQL Alchemy. This cuts down on a fair amount of the boilerplate that I mentioned. So, using an object relational mapper, or if you're using a document database, the analog for that is extremely useful and highly recommended. And then schema.py has the actual GraphQL API description, the queries, and the mutations. So here, very quickly, is the app.py. I'm not going to spend a lot of time on this other than to point out that this contains the GraphQL endpoint. Pretty
Mic
much always,
off.
at least in Graphene, your endpoint is always called GraphQL. And I've enabled a dev tool, which would be the in-browser IDE that I also mentioned. That's where GraphIQL equals true is set. For production code, you want to turn that off. It's a resource hog, and I wouldn't call it a security hole exactly, but it's an extra resource that could reveal data that you don't necessarily want to. So great for dev, turn off for production. And here very quickly is the SQL object relational mapping. So what I've done is set up some data for the Hogwarts School of Wizardry that contains information about some students, some staff, and then their houses. Here is the representation of the house database. It's fairly simple. Name, the location on the Hogwarts campus, who the founder is, the colors, the crest, the ghost. I also have similar representations for staff and students. The staff and student models look very similar because you basically have a name, a house, and some wand data. Oh, and also SQL Alchemy lets you declare types and provide some documentation, and also lets you say whether a column is nullable or not. The default is that a field is nullable. Oh, and also lets you set a primary key and foreign keys as well. These will all map over to GraphQL types, which is why it kind of cuts down on the boilerplate. And basically, here it is. The house node is the GraphQL data type that takes the SQL Alchemy type and takes all its fields and documentation and metadata about the field, the fact if it's a primary key or a foreign key for relational type data, whether the field is nullable or not. Okay. And here is the view of the entire schema. I've marked out where the types happen to be. So we've got house nodes and house connections. I'll explain what a connection is a bit later. And then we've got mutation actions. So I've set it up so that we can create a student, we can change a student house, and I'm being very specific about that changing that particular field. It's better to be very specific about changing fields, I think, than to try and change an object entirely. And also we can delete students. And then we have the query class that handles any types of query on our data, and then mutation that allows us to run our mutation actions. And then we have the declaration of the schema with the types we've declared, the query, and the mutation. And again, all this code is available in GitHub, so I think it's a lot clearer if you try to build it and run it yourself and play with it.
Mic on.
So this is the GraphIQL in-browser IDE. You can see here that there is a documentation pane that when you click on those links, query and mutation, you'll basically get the schema. You can see here that I've got a couple of queries on the left-hand side. My house enrollment query returns students and their information. GraphQL also assigns unique identifiers to data object, instantiated data objects in the system. And then you can also see some pagination information. If I had a very long list, I could just page through using start cursor, end cursor, and check has next page, so I don't overwhelm the system just with a massive data dump. And you can also see that there's slicing with sort and or with the last argument. This basically supports Python list-like slicing. And there's a little arrow key that, or arrow icon that you use to actually execute these queries. Prettify basically cleans up your JSON in the view, and history actually keeps track of, while the application is running, all the queries and mutations you've run. Any questions so far?
Specifically yet. We had a couple come in about added complexity, what GraphQL would be good for versus not good for, but that seems to be, I think we have some good answers there.
Okay, fantastic.
I did ask a question on the chat for Zoom. Just wondering if the IDs that are assigned are like per call to the system, or per session, or per daemon boot, or are they not ephemeral? They start to disk, or?
They're ephemeral and they're per application, so per GraphQL process.
Okay, thanks.
Yeah. Okay, so just breaking this down with a little bit more detail. A root field, if you want to look up a house by its name, is house by name. And then in the payload, house contains a lot of information, as you see on the right-hand side. In this, I'm limiting the amount of data in the payload that I want to get back to just the founder, the location, and the colors. So this would be the not over or under fetching data. And note that I made the house name a not nullable field. So in the documentation, you get this little exclamation point, just as an indicator of which fields are not nullable. Also ID, because that's your identifier. And that also maps to identifiers in the database. I made the ID column the primary key for pretty much every object in this particular example. And here is the implementation of that house by name query. So house by name, and then the Python code. So it's a field. It is a GraphQL type field that represents the house type that we got from SQL Alchemy. And I am going to take the name and then do a query into SQL Alchemy. That would be the housenode.getQuery code. And if I don't provide it a name, I actually can return a fairly reasonable error message or raise an exception, and then do a filter and return the single result, because I just want, house is supposed to have a unique name. So that's why I'm returning one object or one result. Also, it's good to note that I'm basically using snake case for Python, but Graphene then takes all those names and turns them into camel case, because camel case is the standard for GraphQL. That can be a little bit weird if you're not used to it. I know it kind of threw me at first when I started writing GraphQL applications. Oh, and I think I forgot to point out earlier, there is a standard naming convention in Graphene. You declare a name, and then when you want to write some code to actually resolve data on that particular field, you have to name your function resolve underscore, and then the name of the field. So just something else to keep in mind. But this is really well documented, and if you don't do that, the whole thing breaks fairly easily. So it's easy to tell if you've forgotten. Also, instead of just like an object, you can return a fairly simple list. this would be the list, the simple list in the spec. And when you run your query against SQL Alchemy, instead of saying first or some other positional function, you can just say all, and it'll give you all the matching results. So if I wanted to search for staff member by position, like say professor, this would give me all the Hogwarts staff that happen to be professors. And this is where GraphQL is powerful, because we've got some connected data even in this very tiny trivial example. For example, every student has a house. So if you want to capture the relationship of student and house, you can I set it up so that you can search for a student by name and then ask for a house in the payload. And then house resolves to the different fields that a house would have. So the name and the crest. So here I'm searching for Hermione, who happens to be in Gryffindor, that has the lion crest. And another thing to notice in the IDE is that I've set up, instead of just putting the name string in the query, I've got a query variable. And you can have more than one query variable in that window and refer to it by name. So this gives you some nice tools to actually go and test different kinds of inputs as you're developing your API. And this is how we capture that connected data relationship. So in the student model, house is a foreign key, and I'm keying it on the house ID because, as I mentioned a few slides ago, the primary key for all the models in this example are the ID. And then when I resolve student by name, it actually goes and searches for all the student data, including that house field that it has a foreign key to the house model. Is that clear so far, I think? Okay, moving on. And just to give you some, I guess, a comparison between what a REST solution would look like versus GraphQL for that query. If I wanted to get student and then the student's house information in a REST application, I would have to go and get the student with an ID by name, get the student's house, go and get the house's information, and then the name and the crest. So that's 4 separate HTTP GETs. Whereas if I want this information through my GraphQL solution, I just send it that little snippet of JSON and get back all the information that I want. So this is where the real power of GraphQL is, because if you can imagine a rich featured mobile app where you're pulling a lot of connected or complicated data, having to make multiple REST calls over that unreliable network with limited bandwidth means you might end up dropping connections or have to keep polling to get data. So there it is.
Mic on.
So I did say I would talk about Relay. How's everyone feeling? Should we continue? Because the stuff is pretty interesting. It's a little bit extra for the graphene. Okay.
I've tried Relay before, but I didn't get the point, so maybe this will help.
Yeah. So at ARUP, we actually did use Relay in our production code to kind of simplify mutations and cut down on the boilerplate. So I guess I can I'll explain, some of the lessons I learned and why it's good. I guess I didn't show any basic graphene mutations graphene itself basically lets you do whatever you want to mutate data, as long as whatever function you implement ends up in the mutations class. One thing Relay does is it imposes some structure on mutations, which is nice. It also gives you much more powerful list operations when you're returning lists of data. So it gives you sorting, slicing, pagination, and cursors. It does also give you some unique IDs, so you can refetch objects. I'm not sure, it's not like a full-on caching solution, so I don't know if you're dealing with a lot of data, how useful that is, but maybe you could build out a more sophisticated caching solution than Graphene offers with Relay's global IDs. So basically, a connection allows you it gives you kind of like a hook between two related nodes with your edges list. So you declare a connection and what kind of nodes it's going to connect. Sorry, that term is really overloaded here, but that's essentially what that means. And then when you go and fetch all these related nodes, you treat them like a list, so you can slice through them, you can paginate. The only thing you are absolutely required to have for a connection is this meta class, this meta inner class, and to tell it what kind of node it's going to support. But you can add other fields if you want, and resolvers. For example, for debugging purposes, it's kind of nifty to be able to count how many of the node you actually have. So in our case, this is a student connection. It connects up students, and it's handy to know how many students are actually available in the system. We get the data types from the SQL Alchemy model. This is basically where the globally unique IDs get produced, and edges are your node list. And here's what this actually looks like inside the IDE, expressing a one-to-many relationship. This is where Relay is really powerful in simplifying the code you need to represent a one-to-many relationship. And again, also, this is where GraphQL tends to shine as well. So the one-to-many relationship here is our house, Gryffindor, and then getting all the students that have enrolled. Just as kind of an artificial example, I'm slicing the list with only the first 2 students that it would return, just to show that what the cursors and the next page would look like. So you would keep asking in your variables for the next cursor as you continue. Here in this after argument. So yeah, that's basically what that looks like. So this is the implementation for that house enrollment query. I create the connection, and then I resolve on the students. I create a students list, and then I have to go and get a node with a unique ID. Yeah, okay. So yeah, that's basically all the code. As long as you have your resolvers set up, it is very easy to then go and get any of this data that's interconnected, that has one-to-many relationships, or even sometimes many-to-many relationships. But really where it's most powerful is one-to-many. Where'd my mouse go? Sorry. It's a little bit tricky over Zoom. Okay, so then this takes us to mutations. We've got the create, the update, and the delete functions. So the first thing I'm going to show is create. So when you're using Relay, it requires that you take in a unique ID, and so that would be the client ID mutation. And then you have to declare an input class. So all the information that you would need in order to create a student. I skipped over, or I hid the slides that actually talk about deprecation fields. So the original implementation had a field that was just wand and took a string description of the wand. Here, I've broken it out into the various qualities of a wand in the Potter universe. So you can look at the code or the full deck of slides if you want to see what the deprecation mechanism looks like. So I have this class to create a student, and then in order to create the mutation, I have to take a student object, and I'm returning a Boolean for success, because otherwise I have no real way of knowing whether this worked or not. And I'll implement setting that success in the actual code that performs the mutation. So in order to implement the mutation in Relay, you have to implement this mutate and get payload class method. So in order to add a student to a house, I have to get a house object to add it to. And then I construct a student model from the data that I was given. And then I add the student. I do that through SQL Alchemy because I have to add a student model, which will then add it to the database, do my commit, and then return the student object. It's a good practice to return the object that you've created, because even though I'm setting success to be true, you might want to introspect the new student that you've created. Oh, and also I should point out that I'm using keyword args here. I'll show another example where you can use positional arguments. Relay doesn't have a very strong opinion about which one you should use, so that's up to you. There's advantages and disadvantages to both. Excuse me. And here is what creating a student looks like in the GraphIQL IDE. Mutation instead of a query. You basically list out the root field and the payload. And then in the query variables view, I've given all the data for creating a student. You'll notice that to create a student, the student, I put him in the wrong house. So we'll see how to update that information in the next couple of slides. Because if you remember the Harry Potter stories, Dennis Creevy should be in Gryffindor. Also, I didn't include the wand data. Those are nullable fields, and I actually don't have that information from the books or the movies. So that's a legit use case for not supplying that information. Oh, and here's the unique identifier for the student that was created. As you can see here, this is the student object that was created and success being set. Okay, so I put Dennis in the wrong house, and I need to change his house from Ravenclaw to Gryffindor. So this is how we're going to do it. We create a change student house mutation. Again, we have to create that class input. So we take a house name, and we're going to reference the student by that unique ID instead of listing out, name and other identifying information, just to make sure we actually get a unique match. And then we are going to return the change student and success. And then once again, we're going to implement the mutate and get payload function, this time with positional arguments. And if you do this, you have to make sure that you include this client mutation ID, because that's core to Relay's implementation, keeping track of those globally unique identifiers. You can see in the body of mutate and get payload how I can take that unique ID and turn it into the identifier in the database just from global ID function. And then I go and look up the student, and then I change the house that's associated with the student. I commit it to the database, and I return the field, which contains the student and whether it succeeded or not. Are there any questions around this? It's very similar to the create operation. Okay, moving on. And here is what that looks like in practice. And I've added the changed house input to the query variables, run the mutation, and Dennis is now in Gryffindor. That's automatically generated by Relay to keep track of all these different operations. So if you wanted to, it could be part of a caching system, or you can just log it if you wanted to keep track of all the different data ops that happened in your system.
Is that how Relay enforces like serialization?
I don't think it's about enforcing serialization, because that's in the GraphQL spec.
But didn't you say the spec, like it's in the implementation though? But
Yeah,
serialization?
Yeah, but that would be part of Graphene rather than Relay. Relay is kind of adding these IDs on top of Graphene's serialization. Oh, actually, sorry, no. Sorry, I don't even remember my own code. This is my example of showing you how to override what Relay generates automatically, just for fun. So if you wanted to keep track of your own IDs, that's what you could do. I don't know if it's super useful or not. I mean, just using the ones that Relay generates for you works just fine. But yeah, just as an example. Sorry, I wrote this code ages ago, so. Okay, and finally, our delete operation. It's actually pretty straightforward. Again, we take in the identifier for a student, and we write our mutate and get payload, and then we simply look up the student, we delete it from the database, we commit, and we return the deleted object. You'll notice that I'm constantly returning objects that I've either created, updated, or deleted, again, as a best practice. And here it is in the IDE. So I've deleted poor Dennis Creevy. Well, he dies at the end of the last movie anyway, so. Yeah, if you haven't seen it by now.
Mic off.
That's it.
Mic on.
So once again, there's all the code. You know, if you want to dig into this, I tried to make it as complete as I could with half decent documentation. So, any more questions?
Thank you very much, Ayla.
No, thank you.
Sending all the clap emojis right now. Clap emoji, clap emoji, clap emoji.
Thank you, guys.
So for questions, let's take a look. Nothing specific except for the ID thing, and then the mutation ID was a question I had that you answered because you're awesome. Great spot for inheritance from the model. Do you want to clarify what you mean by that, Dylan? You said this seems like a great spot for the inheritance from the model to not
Oh,
need to redefine the fields.
yeah, that was for the relay on the
Oh.
node that you defined.
You can totally do that.
Yeah, no, and that was actually a comment on it. So out of context, it was
Yeah.
more of a like thumbs up than a question.
But yeah, no, your point is exactly spot on, because we wrote some base objects that had some common fields, like to represent. Actually, it was to represent chromosomes and other useful genetic information, and then using relay, and then we created like an inheritance hierarchy to represent different variations on those classes. So yeah, you're absolutely right.
All right, are there any other questions? Okay. Well, thanks again, Ayla, for presenting. Let me just switch things over here. So next up, we got our raffle. We're still doing the raffle. And what I did this time, so what I did this time for our raffle is I did a /who on the, here, let me just show you the code. What am I talking about? We have code. Boop. And unfortunately, everybody's going to have to wait 30 seconds to actually see the code, but that's all right. But later you can take a look at the stream. But all I did is I did /who in Slack. That's a fun command. I bet everybody's trying it right now. And what that will do is give a list that is comma separated of all of the Pythonistas. So then the next thing I'm doing is I'll make a new variable called Pythonistas list, and then it'll be Pythonistas.split, and then you take the string and you turn it into a list by giving it its delimiter. In this case, it's a comma, and delimiter just means, hey, what is the difference between objects in this string? And then the winner is selected with a random.choice. And yeah, I'd love to share my screen, but it'll just crash everything. So I'm just going to hit this run Python file in terminal button in VS Code. And it looks like is Joshua Lawrence on the Zoom. He got to be on the Zoom. That's what I'm thinking. No? Maybe not?
I don't know. This seems a little rough.
I know, it's really rough. You know what's funny is when I ran a test case, Todd McDaniel actually won. So I'm just going to give it to Todd, if that's all right with everybody. But I will paste up the code and yay! And then, yeah, Todd, if you want to DM me your address. Oh, look at all the claps. I like all the claps. We'll get that taken care of. I am going to end the stream fairly soon and end the meetup fairly soon. However, this Zoom call will stay up for a little bit because it's one of those paid plans, so people can feel free to take over this Zoom and catch up and network like we would after a meetup anyway. I would encourage that before you do so, please watch the rest of the stream. I made one more video for y'all. I miss everybody. I can't wait to see everybody again. It's going to be really good to see everybody again, actually, in person. I hope everybody's holding up well. If you feel like you need anything or you just need to talk to somebody, just reach out on Slack or Meetup or anything. Just hit me up. I'd rather talk to you while feeding my kid at 3 in the morning over some chat than just hear that you're not doing so well. So feel free to hit me up. I'm sure everybody in this community is just lovely. I already know they are, actually. So feel free to reach out. And yeah, until then, I will see everybody on May 6th, probably online, and enjoy the rest of the stream.
Thanks, Ferris.